Hi, this is Mrs. Kidman, and in this video, we are going to be discussing some additional trig ratios that go along with sine, cosine, and tangent. Now, you may be wondering why we want these. Well, when it comes to using trig ratios, especially when we're using trig ratios to solve for missing sides, what we notice is oftentimes we end up with something like the sine of theta is equal to the opposite over the hypotenuse. And then we end up with a triangle that looks like this. And we've got theta here, and we've got, this is a 4, and we're trying to figure out what the hypotenuse is. And we end up seeing something like the sine of theta is equal to 4 over the hypotenuse. And we have to solve for our hypotenuse, and we're like, oh, I can't just multiply it. And although it can be solved, sometimes it's frustrating to do that extra step. So there are additional trig ratios that we can use that are related to sine, cosine, and tangent. The trig ratios are called cosecant, secant, and cotangent. And they're kind of the pair or the opposite that goes along with these trig ratios. So let's take, for example, sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, this is not the combination of all of the sides and all of the different sides that we can choose from. If we have 3 sides and we're choosing 2 of them, because it's a permutation and the order matters, we actually have 6 different options that we have here. We can either get opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent, which are the sine, cosine, and tangent. But we also can get hypotenuse over the opposite, hypotenuse over the adjacent, and the adjacent over the opposite. Now, these are additional trig ratios that we use, and they have direct relationships with those other ones. So sine has a relationship with cosecant, because cosecant is the hypotenuse over the opposite. Secant has a relationship with the cosine because cosine is adjacent over hypotenuse. Well, secant is hypotenuse over adjacent. And then tangent has a relationship with cotangent, surprise, and another tangent, where tangent is the opposite over the adjacent and the cotangent is the adjacent over the opposite. So just like before, these are 3 trig ratios that we can use to then solve and find sides. So let's take a second to find these different trig ratios here. So using this triangle and this angle theta, let's go through and just find sine, cosine, tangent, cosecant, secant, and cotangent. Let's take a second, figure out what these are. So sine, remember, is opposite over hypotenuse. So this is going to be 4 over 5. Cosine is adjacent over hypotenuse, meaning that this is going to be 3 over 5. And tangent is opposite over adjacent, or 4 over 3. Now, cosecant is the opposite of sine, meaning that it's hypotenuse over the opposite, or in this case, it's going to be 5 over 4. Our secant is the hypotenuse over the adjacent, meaning that this one is going to be 5 over 3. And then our cotangent is the adjacent over the opposite, so it is 3 over 4. So you can see how it relates directly to those. So let's take one more second to figure out what these different things are. So let's find the cosecant, secant, and cotangent of this triangle here. So the cosecant, remember, is the opposite. It kind of pairs with sine. So this one is going to be the hypotenuse over the opposite, or 61 over 60. This one is going to be the hypotenuse over the adjacent because secant goes with cosine. So this is going to be 61 over 11. And cotangent is going to be adjacent over opposite because it is the opposite of tangent. And so we are going to have 11 over 60. Now, this is awesome, but what if we had to find angle theta? Well, knowing cosecant, secant, and cotangent is awesome, and they do actually have their own inverse functions, just like sine, cosine, and tangent have their own inverse functions. However, on a typical calculator, it's not easy to find that inverse function. So what we have to do is we actually have to rewrite one of these in sine, cosine, or tangent and use that. So how do I find the cosecant of theta? Well, that would be the same as the sine of theta, which would be 60 over 61. So how could I find theta? Well, I would do the inverse sine of the opposite, or 60 over 61. We can kind of see what that is. So if we do the inverse sine of 60 over 61, we end up getting 79.61. And it should work for all of these. So if I do the inverse cosine of 11 over 61, we should get the same thing, which we do if we do the inverse tangent of 60 over 11. We should also get this, and we do. So 79.61 is what that angle measurement is, and we can use any of those inverse functions, but we do have to change them into sine, cosine, and tangent. So let's take a look at a couple of examples here where we're not given a triangle, but we need to find different pieces. So in this case, we want to find the sine of theta. If cosine of theta is 7/25, remember cosine is adjacent over hypotenuse. So as I draw my triangle here, here's theta, my adjacent side is 7, my hypotenuse is 25. So I want to find the sine, so we can use the Pythagorean theorem to figure out what this is. The other thing that I would really keep in mind here is actually those special right triangles and the options that come with those. Because when we use our special right triangles, we actually sometimes can skip doing that Pythagorean theorem. So here, as a quick disclaimer, are some of the special right triangles that we're going to end up seeing. We can have a 3, 4, 5. We can have a 5, 12, 13. We can have a 7, 24, 25. Hey, look at that. We have an 8, 15, 17, 9, 40, 41, 11, 60, 61. There are lots of options like this, 12, 35, 37. We can see that there are many different Pythagorean triples. So this one actually is this Pythagorean triple here. So we know this is 24. And so if that side's going to be 24 there, then we want to find the sine, which is opposite over hypotenuse. And so to find the sine of theta here, we're going to take our opposite side, which is 24. So the sine of theta is going to be 24 over 25. Awesome. Let's take a look at 2 more examples here where we do the same thing. So now we want to find the cotangent if the secant of theta is 17 over 15. Okay, so secant, remember, secant goes with cosine. So this is going to be the hypotenuse over the adjacent. So here's our triangle. Here's theta. My adjacent is 15. My hypotenuse is 17. And a leg of 15 and a hypotenuse of 17 is actually called an 8, 15, 17 special right triangle. So if we want to find the cotangent of theta, remember cotangent is the opposite of tangent. So if tangent is opposite over adjacent, this is going to be adjacent over opposite, meaning that the cotangent of theta is going to be 15 over 8. Awesome. Let's take a look at one last example here. In this case, we want to find the cotangent of theta if the tangent of theta is 7 over 24. So here's my right triangle. The tangent is opposite over adjacent. Now I need to find the cotangent, and cotangent of theta, remember, is the opposite of tangent. So it's actually just going to be our adjacent over the opposite. So we don't even need to find our hypotenuse here. So the cotangent of theta is going to be 24 over 7. So you can see how these different trig functions work. They're just like sine, cosine, and tangent, but they switch. So again, those are the cosecant, which goes along with sine, the secant, which goes along with cosine, and the cotangent, which goes along with tangent. So using these different ratios, we can actually interpret and solve for different values based on what our trig function does. If you have any questions, feel free to reach out, but that is an introduction to these additional trig ratios. Please check out the next video in which we use these trig ratios to then evaluate some trig statements or some trig expressions that involve more than just sine or just cosine. We might see something squared, we might see multiple of a trig function, because remember, these trig functions are just ratios. So please check out that next video in which we talk about how we can use trig ratios and combine them together.